Okay, I'm going to demonstrate VLAB, Virtual Lab Environment. It's a do-it-yourself virtual desktop for instruction system we created. It's up in the cloud. First of all, if you go to vlab.cloud.vt.edu, it looks for an authentication token from the school. If you don't have one, it instantly redirects you to the login page of Virginia Tech. I give it my faculty, staff, student credentials. Instantly gives me a login token after I pass dual factor authentication metrics, and passes me through to the VLAB desktop environment. This is the actual GUI to the desktop environments. This is the instructor view. You can see here, I can see all the students and their desktop um, images, and then I can see who's logged in at any given time. I go ahead and click on here. We set this up for the AOE, Aerospace and Ocean Engineering department, for doing fluid dynamic simulations on. They had a requirement that they be able to run a fluid dynamic simulation package called OpenFoam that required virtualization technology be turned on in the processor BIOS level of each student laptop, and it was a huge pain. A third of the class couldn't even run the software, and they were tired of having this class turn into basically a big IT session. So they wanted to unify the software experience for the students. So we took all their software requirements, put it up here in the cloud on this Ubuntu image, and it runs very nicely. It gave them some 3D modeling software so they could create three-dimensional objects, then pump those over here into the OpenFoam container. Let me just simulate some work as if they were doing something over here. You can see it's very responsive, just like being on the box. But to simulate some work, and then they would go ahead and take the output of the fluid dynamic simulations and pull them up in visualization with ParaView or some other visualization package. To make sure the system was responsive, we gave it a couple cores and 4 gig of RAM, and gave it full internet access so they can get out to, for example, Google Drive, download their homework assignments, upload any like quizzes or test results that they're running on the cloud, in the cloud. Also, they can get out to things like GitHub if they're doing computer science, like coding type things. They can then download their code and work on open source projects. And I did some benchmarking using videos to make sure that it was responsive enough that it was actually not going to be a pain for them to use. This is all inside a web browser, by the way. You can see it takes the virtual desktop and scales it infinitely up or down to whatever the student's native resolution is. It doesn't change the resolution of the actual desktop experience itself. It just scales it very, very quickly. So work on a tablet or a phone or any type of device that has an HTML5 compliant browser. After they were done doing whatever they're doing, they could jump out, and the best idea is to have the system automatically shut them out, shut down the system when it's not being used. You save an order of magnitude more money when you do this automatically as opposed to leaving it running, which would be very expensive, about $1,300 a month if you left it running for a class of 30. But as it is right now, we can get, for a class of 100, we can do all of this for about under $20 per student per semester. So just around $2 per student per month, essentially. So it's a really good deal. You can see the instructor can see exactly what's going on the student's desktop and get in and take care of anything that's going on there. You can go down here and monitor, see what students are currently logged into the system. It's very responsive, very economical, and a great way of getting rid of some of the physical legacy computer labs and unifying the students' software and desktop instruction experience overall.